Desktop Expert. What up, G's? It's the Desktop Expert here, having a look at this project, the Marinus link, which is a link between the renewable energy assets of Tasmania and mainland Australia. Solar and wind here, with a bit of coal in the mix, and a lot of wind and hydro in Tasmania, and how they can interconnect better and store the surplus and release when needed. Now, this is the current proposal. We've got our grid, the southeast interconnected grid here. Tasmania and Victoria already linked, and this link has proven to be very successful. Times of low water, or when the coal fire is producing at night and Tasmania can save their water and use it at times of peak demand and export that power at a great profit. So what we can do is just talk about this link, and there's a number of massive possibilities here for a scheme that I call pump and dump hydroelectricity. So let's have a look at the scheme here. So we've got wind, solar backed up with battery and gas-fired power in South Australia. In Victoria we've got wind, solar, gas, but the nasty thing is in this area here we've got a lot of brown coal. Nasty brown coal. In the middle here we've got the Snowy Mountains scheme, which Snowy 2.0 is going to be a massive hydroelectric pump storage scheme there. We've got Sydney. Now in this area of New South Wales we've got a lot of black coal being wasted on boiling water to make electricity. A lot of those assets are going to be retired in the near future. So what we've got here in Tasmania is wind and rain. Very good for making electricity, especially on the west coast here where we get some like 3 meters of rain. Got a lot of topography there, which is very suitable for hydroelectricity. So let's get on to Google Earth and have a little bit of a squidgery-didge at what I would describe as a better way to do this Marinus link. Now, let me just level up the map. Now, in South Australia, we have a lot of power lines coming down this way, joining into Western Victoria. We've got 3 interconnectors going across there, and then in the future there is talk of an interconnector linking South Australia directly to New South Wales. So all this solar and wind energy can be exported at will, and off-peak power can obviously be transported to South Australia to be used there when the wind and the sun is not favourable. So, at present, they propose that these power links will go into the Latrobe Valley. Now that is a good idea because we have a lot of distribution and transmission infrastructure in the Latrobe Valley that will be underutilised when these brown coal power stations here start to get decommissioned, as is already happening. And we also have a proposal here for a massive offshore wind farm that will, for the large part, take advantage of that transmission infrastructure. So if we want to bypass Melbourne and the Latrobe Valley, we're probably best to go this way from Western Victoria, where we can link the enormous solar power potential here with the renewable assets of South Australia, where we can link that more directly with West Coast Tasmania, where all the hydro assets are. And there is a side benefit here, is that we could link in with the wind power assets that can be constructed on King Island. So, when we get down here, we see Tasmania. Beautifully wet, lots of topography suitable for dams, and plenty of potential to make this water work harder for us in the area of storage. So let's have a little squidgery-didge at this potential scheme here that's already been mooted, but I've just improved it. Now here we have this West Coast system. Now we've got a number of dams. They just cascade down eventually into Lake Pyman. I believe this is the Arthur River. Dump out there, cascade, make a bit of power at each stage. Let's do it better. Let's use what I describe as pump and dump hydroelectricity. So here at the top of the catchment here, we've got Lake Plimsoll. Now, Lake Plimsoll has the ability through this system of conduits here to grab a lot of water off these mountains where it's very, very wet, put that water in Lake Plimsoll, and then cascade it down this system. Let's do it a better way. Let's do pump and dump. So, here's Lake Plimsoll. Click. Here in between is a mountain. And then down here we've got Lake Pyman. Okay, let's make the link. Now, altogether those things are only 13 kilometres straight line distance. So we've got Lake Pyman here at 500 metres. In the middle we've got this mountain that's over 900 to 1,000. So there's a potential to use some of this topography here for an upland reservoir. Let's have a look there. Oh look, they've already built the reservoir for us. There we go. Over 1,000 metres that lake is there. So we have the potential to pump up with off-peak power and dump when power demand is at its greatest. In a normal pumped hydro system, you pump up and down, but you actually lose energy because the pumping up requires more energy than you make from dumping it down. But in a pump and dump system, we're pumping up a little way to drop a long way. Now the compromise there is that we lose the water. We can't just continually cycle the water up and down. But the gain is that we make energy from this process. It's a net gain of energy. So what we got here, we go up from 500 up to over 1,000 metres. So we pump up 500 metres, and then, so we're going from 1,000 down to 127. So we've got a 870 metre drop we can do there. So this is a way that we can use pumped hydro to actually create more energy than we use in the pumping scheme. So this could be a very lucrative scheme for Tasmania, using the off-peak power when the sun and the wind is blowing hard to store energy and drop when the prices are high, when the energy is in high demand. Is this a radical idea? No. Let me blow your minds, because if we cycle the map over here to the Great Lakes, this is already happening. From the Great Lakes, they already drop water down here to this tail race, which is called Pautina, I believe. Now, from this scheme, we get about an 800 metre hydraulic head. But it's not just that. This scheme is more complex than that, because we have this Arthur's Lake. Now, in the olden days, Arthur's Lake used to just have a little power station here somewhere, drop the water down, not get much bang for our buck. But now, what they do with Arthur's Lake water is pump it up from there to there. That's about a 50 metre difference in elevation. So this water can now have the opportunity, with 50 metres of pumping, we can now drop that water 800 metres to get maximum bang for our buck. Now that is a classic pump and dump hydro system that's already in operation. Now the one I showed you over here at Lake Plimsoll is small bickies compared to one that could potentially be built in this particular area down here at a little lake you may have heard of called Lake Pedder. Now Lake Pedder and Lake Gordon are linked. There's a canal through here somewhere, so water is transferable. Now with a bit of engineering it could be more transferable. Now Lake Pedder's there, ocean there, and there's a high range of mountains through here. So what we'd need to do is find some kind of location up on top of this mountain here where we could get some kind of spot. Now here we've got an elevation above 900 meters. There's going to be a spot in these mountains somewhere where we can get an elevation around 1,000 meters. Now let's say for the purposes of this exercise that we can build a reservoir at 900 meters. So we've got our reservoir up there at 900 meters. So we're basically pumping up 600 meters, and we can drop straight into the ocean for a full 900 meters of hydraulic head. Now this is a big scheme. There'll be around 37 kilometers, 35 kilometers of tunneling involved, and a reservoir built up on top of a mountain. And as you can see though, the potential gains here are enormous. We pump up 600-ish, and we get a potential hydraulic head of 900 meters. Potentially even 1,000 if we can find the correct location in these mountains here. So we have the potential to get a massive gain from a pump and dump hydroelectric system here. And as you can see, within these two lakes, there's a massive amount of water available to make this scheme a very, very worthwhile investment. So that is the Marinus link, or the Marinus link. I'm not sure exactly how to pronounce it. So we basically have the potential to connect these pump and dump hydroelectric schemes here in the west coast of Tasmania to the renewable energy assets of Western Victoria, which is just absolutely rich with wind, solar, and also the renewable energy assets of South Australia. And then export that power into the energy hungry markets of New South Wales and Victoria. So that is my contribution to the debate on the Marinus link. I hope I'm pronouncing that correctly. Stay tuned for further videos where I will sit at my desk and explain the wonderful ideas that I may or may not have. Thanks for watching. Desktop Expert.